working with symbols unit 3, it's the higher course, page 37 onwards. Now 3.1 talks about expanding brackets and then collecting like terms. So, well, I don't know, let's just do one or two from question 1. It's only grade D, I won't do too many of these things because it's basic. So, I don't know, question 1D, I'm going to do this one. It says this. It says 3 open bracket 2p plus 5. Well, that means, if you recall, 3 times 2p, 6p, 3 times 5, 15. We can't simplify that any further. 6p and the 15 are two different terms, so we can't collect like terms because there aren't any like terms at the moment. So that's that done. I'll do, I don't know, J. It says this. It says 2d, please note number and letter, 2d multiplied by 3 minus 5d. Don't be scared of the minuses, just do the maths. 2d times 3, well, 2 3s are 6, so I've got 6d's. 2 times 5 is 10. D times d is d squared, but the whole thing's negative. There it is. And I still can't squish them up because a d and a d squared is different, so I can't say I've got minus 4d squares or something, because that is only a single d. And I'll do the last one as well. It says 6t multiplied by t over 2, in other words half a t, and then subtract 2. So let's just do that carefully. 6t times t divided by 2. Well, what have I got? 6t times t is 6t squared, and it's divided by 2. I'll deal with that in a minute. And 6t multiplied by 2 is 12t. Got it? But it's negative, so put a minus there. Going a little bit further, 6 divided by 2 is 3. So I've got 3 lots of t squared, take away 12t. 3 is very boring. Write an expression for the area of each of these things. Well, I don't really want to do that. It's just an area of a rectangle. Okay, go on, 1. We'll do 1. We'll do 1. Let's pick one of these. I've got here, I don't know, let me just do C. I've got here 4c plus 3, again algebra, multiplied by 6 here. So essentially I've got 6 lots of 4c plus 3. Don't be baffed by it. 6 times 4, 24. So I've got 24 c's. And 6 times 3 is 18, and it's positive, so that's that. Very, very boring. Now we're going to do some dangerous grade C work. Alright, so this time we will have some like terms, presumably. This is question 4c. Right, so you know where we are. This little guy's going to be in our way because he's all dressed in yellow. Never mind, let's work down here. So I'm going to work down here. Right, let's do a baby one. 4 bracket n plus 2. And then subtract what I like to call the dangly bit. That's what gets in the way. Right, 5 times n, 5n. 5 times 2 is 10. Oh, then it says minus 10. They go bye-byes. Answer 5n, because 10 take away 10 is nothing. If you like, I've collected like terms and I've eliminated the plus 10 and minus 10. Let's work over here now. I think I'll do this one now. 7 bracket 3 minus 2n close bracket plus 10n. Multiply out. 7 3s are 21, 7 2s are 14, so I've got 14 n's, but it's negative. Now add on 10 n's. Now don't go throwing away your marks now. 21 is the number 21, it's not 21 n's. I've got minus 14n plus 10n. Minus 14 plus 10 still leaves me on minus 4, so I've got minus 4 n's. Okie dokie. And I'll do the last one because it looks dodgy. I better just turn over the page. I need a fresh go at this one. So 2 bracket n plus 1 plus 5 bracket n minus 2, and take away the dangly bit, which is 4 n's. We'll just bust this all open. 2n plus 2, going glitchy. Come on. Right, 2n, 2 times 1 is 2, is sorted. 5 times n is plus 5n. 5 times 2 is 10, but of course it's negative, it says minus 2. And we're not saying 5 times minus 4, no, that is not trapped in the bracket, it's simply minus 4n. Am I in the right place here? Now let's squish it up a little bit. We're going to collect some like terms. 2 n's, 5 n's, take away 4 n's. 2 plus 5 is 7, take away 4 is 3. So this becomes 3 n's. Now we're going to do the numbers. 2 minus 10 is -8. Answer is 3n minus 8. That's it. Blah de blah de blah. Well, this is shapes after all, geometry. So question 5 is find the total area of each of the coloured shapes. Expand and simplify your answer. Oh, okay then. Let's just do the first one. Do it up here. This is 5a. I've got one of these little dooblies like that. It's not as bad as that, but anyway. This is called n plus m, and this is called 6. And this side is called n. Oops. Slipping. Getting a bit glitchy. I don't like it. Stop it. Stop it! This side is called n, and this length is called 5. Now, I've got to find the area. Alright, area. So essentially I've got two little rectangles. I've got this bit up here and this bit up there. Let's just do some sums. There's the top bit. I have got 6. Oh, come on. I've got 6 multiplied by... Right, resuming. I'm going to try and do this. If it goes glitchy, I'm just going to pause it. I've got 6 multiplied by n plus m. I don't know why they're putting an m there. It makes life hard. And I've got, for this bottom one, 5 times n, or just 5n. Multiplying this out, I've got 6n plus 6m's, plus I've got the 5n's at the end. 6 and 5, I've got 11 n's, plus the 6m's on their own. Altogether, that's the area of that shape. Let's turn over, and maybe I'll do one down here, I think. This one looks rather complicated. Now let's just do C. I like it. If I draw the picture up here, then work downstairs. There you go. That's a beautiful square there. That's another beautiful square, or maybe a rectangle. Anyway, this length is B. This length is 5. Upstairs, I've got B plus C. So the big one, and I've got a width of 10. So I want to work out the area of the shaded bit, obviously, because the coloured shape, and that's actually not present. So the big part is going to be 10 multiplied by B plus C. Then of course I've got to take away the area of this B times 5, so it's minus 5B. Is that alright? So I'm essentially working out the area of this bit here, and in your book on page 39 you can see this is actually shaded yellow and this part is white. So multiplying out 10B plus 10C's, and then take away the 5B's, this part here. So 10B take away 5B, I've got 5B's plus 10C's left over, which do not cancel in any way. So that's the area of that shape there. Turn over, and I don't know, I fancy this one. I just do. I assume it's the hardest one because it's the last one. Got this like fat L looking thing here. This is called 3A. This is called 2A. This is called A, and that's called 4A. So it's all A's. Lovely. So what can I do? I don't know really. If that's 2A and that's 4A, if I can read that, yes, I reckon that must be 2A as well. Yeah. How about I just chop it down here like that, and I've got that times that, and then I've got a 2A times an A. That's one way of doing it. So this part alone would be 2A times 3A. It's going to give us 6A squared, and this part is going to be 2A times A, which is 2A squared. Total area is going to be 8A squared. What have I done? I've taken that one and that one, and I've added them to get that one. That's it. I'm sure I could have chopped it across there and done it differently. Doesn't matter. It all works in the end. Maths. That's why maths is such fun. That's it on question 5. Question 6 is silly, so I'm not even going to do that. Question 7 is silly, so I'm not going to do that either. Yeah, well, let me just read it to you anyway. Question 7 is one of these with a dodgy question mark on it. In each diagram, the value of the perimeter and the value of the areas are the same. Oh, are they? In each question, work out in each part which value of x gives the same value. That's just messing around. I'm just not doing that rubbish. I think I do question 8, so one of these things. I've been given this. I rather like it. Don't know why, I just do. I'm told this is called 3y minus 6, and this is just called 2y. And I've got one that goes like this, and I'm told this is 6y, and the length up here is called y minus 2. And I've got to show that the areas of the two rectangles are the same. Alright, so here I go. So essentially multiply this out. 2y with 3y minus 6. That's going to give me 3 2s are 6. That's 6y squared, y times y. And 2y times 6 is 12y. That gives us minus 12y. Now next one, do it over here. I've got 6y multiplied by y minus 2. 6y times y is going to be 6y squared, and 6y times 2 is going to be minus 12y. Proven, same, no problemo. I'll do a bit of question 9, then I'll stop because I suspect this video is getting a little bit long. Right, blah-de-blah-de-blah. Let me just draw you one of these little things. I've got one of these little, you know, this sort of thing. Seen this before? That sort of thing. And I'm told this is 25y squared, and I'm told this is 5y. And here I've got a dirty great question mark. And it says, in the diagram below, the expression in the top box is found by multiplying the two adjacent boxes below it. In other words, that times that makes that. I've got to find the missing ingredient. Well, I can see straight away that 5 times 5 makes 25. And to go from y to y squared, I need to multiply by another y. Answer 5y. I think I'll try B as well, because it's well, it's only slightly more challenging, but not really. So this is me drawing little boxes like so. This is question mark, and this is called 2, and this is called x minus 3, and that times that makes that. Oh grief, it's so easy. So multiply 2x minus 3 with a 2, that's going to give me 2x minus 6. Thank you, that goes in there. The last one looks like a pain, so I think I'll do it. This will be the last question that I do in this section. I've got a box like so, a pair of boxes underneath like that. Note the diagram, it's beautiful. I've got here 2x squared plus 10x. Now here I've got x plus 5. Now it's going to be a bit hard going from there to there. What I'm going to do is factorise the top bit and hopefully end up with an x plus 5 factor. And what's left over must belong to that box. So let me just factorise that. Here I go. I've got 2x squared plus 10x. If I factorise it, I'm going to take out a 2 and I'm going to take out an x. So 2x times x makes 2x squared. And if I take out, to go from 2x to 10x, I simply must multiply by 5. Oh look, my x plus 5 is there, which means the 2x lives in there. Alright, here you go, 2x, bracket, x plus 5, close bracket, multiply it out, takes you back to that. So I'm really happy with that, and that's a good introduction to that, and that's only grade C. And do look at the foundation, excuse me, look at the foundation videos, it's good for you. So I'm going to stop now and save it.